All right, cool. 668. Kth smallest number in multiplication table. Nearly everyone has used the multiplication table, but could you find the kth smallest number quickly from the multiplication table? Given the height m and the length n of an m times n multiplication table and a positive integer k, you need to return the kth smallest number in this table. Okay. Okay. There are a couple of ways to do this. So the first thing that I would look at is the bounds. Looks like it is 30,000, and that means that you have to be smart-ish, because m times n, it's going to be 30,000 square, which is what, like 900 million, so slightly less than a billion. So, but still pretty sizable. So you can't do anything like, so one thought that I might think about is like putting things in a heap, and stuff like that, right? And then just keep on iterating to get the next one. But 900 million is going to be too slow, so you need to be even smarter than that. K will be in the range 1,000. Okay. I think this, and some of this is try to figure out, but I would, because m and n, and you could probably just simplify the phrasing of this to just be n square, or n, because you could always just say, oh, if m is bigger than n, just swap them and you have the same answer. So in terms of n for complexity analysis, we probably need, for 30,000, we need either O of n or n log n. I don't know if we could do it in just O of n. Or at least, like, I don't have any intuitions about it. And n log n means that there's some kind of binary search-ish. So you could always also just do regular binary search. Given that your max is going to be 900 million, log of that is about, like, log base 2, to be clear. Of that, it's about 30. So 30 binary search numbers should be okay. If given a number, we just go through n to calculate how many numbers, or how many multiples of n's are there, and then you kind of sum them all together, and then you check that for against the number of k's, and then that will tell you the answer. And because that operation takes n times, and so it's n times log of 900 million, which is technically log of n square, which is log n, or 2 log n, but then like O of log n. So that's m log n algorithm, right? I think that's okay. And for n is equal to 30,000, that should be, way enough time. So I think I'm going to start kind of going that way. Let me know if I could explain anything better. That's kind of my thought process. Yeah. Well, my current thought process is, do y'all want to see in C++, or I could do any language? And for binary search, it doesn't really matter. I could do it. Okay. How about Java? Let's take an attempt. My Java will not be as clean, so don't. But I mean, so I always appreciate feedback about, like, code and stuff like that. So definitely give me feedback, but don't laugh at me too hard, I suppose. But yeah. So what we actually want to do, my first instinct is just to make the problem a little bit easier. In that, I said that you can always swap the m and n depending on conditions, and now we actually want, because if you think about the binary search and each of them just uses n, and in fact, if you think about it, there's no m in that equation. But at least the log n part is dominated by, oh, sorry, the n part, the constant time of the, oh, sorry, the linear cost of going through n and counting. You could just take the min of m and n because it's cheaper, right? So that's what I'm going to do. That's a really long-winded way of saying it. But yeah, okay. Let's just add a temp. If m is bigger than n, that's okay. So actually, we want the other side because I like using n instead of m. So if then n is equal, oh sorry, t is equal to n is equal to m is equal to t. Just swap them. I don't in C++ you could use swap, I think, but yeah. And then now we do a quick binary search. So again, I use the same ish template a lot. So now we can, well, what is our tail, which is the top part of the binary search? Well, just m times n, right? And just for kind of math, I don't know, bounding, I think I could just add a little bit higher. It would never get there, so it's fine. And then the head is just 0. And then now, let's do head first. Now we just have our standard-ish binary loop. Yeah, I like to usually just keep track a little bit. So I need to be better about this part. That part is on me. I think, okay, let's just actually do this way. Let me, if nothing else, I'll learn something. So this is standard binary search. The only thing I would say is that 900 million. So one thing that I have to think about or want to think about is that, so I write this formula, which is the mid is equal, this is binary search. But if head is 900 million plus another 900 million divided by, so in this case it's okay. But in another scenario, you can imagine that if let's say this is like, 1.1 billion, which is only slightly bigger than 900 million, then this will overflow int, and then this will give you a really sad day. So that's how I would say about it. But yeah, so now, if count of mid, and let's just give in the input, mn. If that is bigger than k, and what I was thinking about is just trying to think about the greater than or equal to, and what happens in the equal case. I guess in the equal case, then you just return it. So maybe that's what I would do. But if the count is greater than k, what does that mean? That means we have more numbers, so then we want to go lower. So tail is equal to mid, else, okay, let's just cache this so I don't do it twice. Maybe, I think with familiarity, I could do a little bit better about this. But else, if c is less than k, you set the head as equal to mid. Otherwise, if the c is k, then they just set head is equal to mid, and then we break, and then we return head. I guess we could just return head then, but whatever, this is okay. And now we need, is there I don't know if it's implicit in Java, it's been a long time, but let's try, what's it called, the product, m and n, because we need them to kind of help our calculations, and in this case, just as a note, n is smaller than m, and then we just have to do the count, right? And again, the first thing that I would think about, because the numbers are getting big, is whether it fits an int, but Does it fit in int? Can you do a little funky? No, no, we're bound okay then. It should still be bound by 900 million. I think in theory you could go way over bound, but right here we're capping it by the bigger number anyway. So yeah, and maybe you could even cache. Maybe you could do. Maybe there's some like even better formula about this, to be honest. But for now, I'm just gonna actually go from I to the smaller one. So I'll do something like this, and then C is just equal to the number that we're testing divided by n. No. Oh no, by I. Why am I? Yeah, by I, and that's kind of the numbers in the multiplication table that you have. But it is capped by m, right? So we want just the min of these two numbers, and also this is an addition, not a. And I think that's roughly right, or at least in terms of coding. Let's take a look. Is that not a? How do I do math done? I thought this was. It's been a while since I've done Java, I guess. I thought that was it. Oh, I think I'm thinking of C# in Java clearly. The the functions start with what you would call it, lowercase. Cool. I don't know if that would give me confidence at all. And now we try the big number. Let's just say, and then again, was it 900 million? I would say in my experience, I've definitely failed a lot because I miscount the number of zeros in the number. But oh no, really? That would be surprising. Okay, let's scale this down back a little bit. Well, let's test at least these first. At least test for correctness, and then we can think about how to optimize. But this is n log n, so I can't imagine that's the case. So I think I just have a minor issue somewhere. Okay, at least that's right, and it happens in 1 millisecond. Okay, let's put. Oh, I forgot. Okay, well that would definitely do it if it's not within bounds. But that's kind of. Let's double check first before I speak, because maybe there's another thing. Huh? Really? Does this overflow? Because this should only execute about 30 times. Oh, I think I'm just being silly. I think one of these has to be because it'll never converge for that reason. I always forget how which one has to be. So that means if mid is strictly bigger than k, then we will never consider mid again, and so forth. Okay. Don't work for the other ones. I don't. Maybe I just got lucky if this is one of the case. Okay, I mean it's wrong answer because it's off by 1. Okay, fine. But still, that means at least there's validation on our algorithm, and it's once in 10 milliseconds. And we send off by 1. At least in this case, it's fine because it's just binary search. But this is the part that, to be honest, I'm always like a little bit weird about. I'm always like off by 1s. I need to kind of reread it. To maybe reread some literature. I think this would, okay, fine. I will maybe reread my literature in the future. Let me just do something hacky. This is my standard. And then what I usually do is, because there's no answer which is the equal, so, okay. Yeah. And then now I just check the first number that goes over it, because what happens is that k is in between two numbers, and I don't handle it correctly. So that's what I'm essentially trying to make up for it a little bit. Oh yeah, yeah, definitely. If you have like, because I do this because it's very like I don't have to prove anything, which is great for competitive programming. But I do want to be more robust about it in general, because I definitely like, you know, like very few people do what I do, and that's not meant to be a. What the? Because now in this case, it tries to go, because you want. Okay, fine. But yeah, this is obviously a little wacky. Yeah, okay. And now we submit. Oh no, off by one. I was wrong. But yeah, I mean, I think like we're mostly there. We just have to kind of handle exactly the thing. But why do I get an off by one though? It's already bigger than k. That means you want the previous number. Is that true? Yeah, I think this is true. Maybe I just, because now I could do a little bit better. Oh no. Did I have off by one here? No, this is pretty solid. I mean, I don't think there's that many places for misinterpretation. Unless I'm off by one on M. No, but no, I don't think so. Unless. No, because there's 3 and then there's almost 3. Yeah, that should be okay. Off by once, but the algorithm is right. But that's why I always advocate practicing it, is because even sometimes where you know exactly what the algorithm is, you may run into issues. And oh, it doesn't. I was going to check for submission time, just making sure that I'm way under the performance time. But why does this? Is there something? I mean, I think I have to think about why is it exactly that this is well, and maybe we could just point it out then. Oh, this is Java system dot out dot print line, is it? I think that also gave me another error somewhere. So let me debug this one. Okay. So on 127, I get 4.1. Is that what? Oh, I think I just there's an off by 1 because I misread k, because I thought it was from 0 to m times n. So actually, So that's unrelated to a lot of fancy stuff I was doing. I just misread some of this problem, which is not that hard to fix in theory. But that also means that some of my hacky stuff to fix it was wrong. But because usually the way I structure these is that I do it by the. Am I wrong? Well, I mean, now maybe my numbers are a little off. Because I like usually do it with zero indexed, right? Because your first number will have one. Off by ones. Yeah. Okay. Well, that's just for. I got most of it right except for now, so I now have to think about it a little bit. Now for this case, what is it even for this case? For 5, actually want 4, but yeah, but now maybe I have an actual off by 1 in another case. That kind of this is what happens sometimes when your thing's kind of wrong in a way that evens out, which is unfortunate. Hey, what's up, Sonny? How you doing? Yeah. I guess maybe I'm wrong on that one actually, because at least the counting function. Yeah, maybe this is not necessary. Maybe I have a different thing somewhere because I think the counting function is a little different than my normal thing, because you want. Well, maybe I still have an off by 1 though, because you want the counting function gives you the exact number, or like given it say 6, how many numbers are 6 or the same, right? Which is illustrated maybe perhaps here where there are multiple numbers. It's like, okay, given 5, given 3, how many numbers are 3 or less? And the answer is 5. But that means if, what's the answer for 4, right? What do I put for 4? And I'm not confident right now that it is right. Yeah, you know, once in a while I try to learn stuff and remember stuff for once. But yeah, so okay, because for 4, 3 returns 5. Okay, so I think I have some. I have to think a little bit about how to count the off by ones. I think that's my issue. But the general algorithm idea is right. Okay. So I think what I want to do actually is count by the number that we're checking for minus 1. Okay. Because then that is the number of all the numbers smaller than an inclusive, which means it is smaller than this number, exclusive. And then you want the next number that's bigger than that number. Hopefully that's understandable. Yeah. I'll just keep this for now, maybe. Come on, Larry. You can do this. Okay, so what did I say stuff again? I don't know if this is still necessarily true. But now, so if this is strictly greater than, what does that mean? That means it's okay, but you still need like, I don't know, but you could still consider the mid. So in this case, I think it's just this, which someone suggested. Good for the heads up. Yeah, I mean, I think it's just all the boundary stuff that I always have little issues with. Why did I even upturn 4? That's not even an answer. Maybe I have another offline one somewhere. Oh yeah, because mid now is, wait, if C is equal to K, what does that mean? I think what I actually should do is just, well, let's kind of get this away real quick. Oh yeah, I'll definitely take a look right afterwards. Okay, so the output I get is 33445 instead of, the array that we're given. Why is that? For the input 1, we want the answer to be 0. Right? And this, did I get the signs backwards? No, that would be cray. Okay. So the mid is bigger than 0, so it tells you the mid. No, this is rightish, but there may be an off by something. What is the last mid? All right, let's just print some stuff out. Maybe Java's bad luck for me. Oops. So we start with 5, and that gives us 6. Is that right? That should give us 6. Yep, that's right. And now we start with 2, and it gives us 1. That's also right. So then now we just try 4, which gives us 5. Also right. So what is wrong? And 3 is 3, also correct. So the count function is right. So that means my if statement is dubious, or at least my return of that statement. Because, well, it's either that or I just put in the wrong thing. No, 331 is right. No, but even 3, where's my left and my right? Why is my left and my right not checking for 0? No, bad ones are hard. Oh, I call it head and tail. Oops. So yeah, so 5. This mid is tricky. Is that what I meant? Okay, then it just doesn't terminate. Yeah, okay. Though it's still wrong to be stuck between 3 and 4. So maybe this part doesn't matter. How did that happen? How did it happen? Because 0 between 2 and 4 is 2. So we tried the number 2. 2 is too small, which, no, it's 1. No, I guess I don't test. I took out the equal case. Yeah, okay, fine. But that should still be okay if the 3 and the 3. And then it terminates, is that right? But it shouldn't, right? Man, it is tricky. Okay, maybe I'll bring back the other thing with the linear helper, and then I'll have to learn stuff offline. Learn stuff offline, yeah. Okay. That means they're exactly. No. Yeah, maybe like that. And then it's going to go in infinite loop because I don't increment. Yeah, definitely. I mean, sometimes you just, one of those things. Off by once, it is what it is. It's definitely. How am I on this palm? Yeah, not link. No, like, wow, I took half an hour on this one, which is a little unfortunate. Yeah. Why? Why is it at 2? Because 2 is what it was testing. Why is the head at 3? Okay, maybe I just have off by once that I'm really bad about. Let's just do it that way. And this is why I usually do it the way I did, but I will try to figure out how to learn offline. Do I have to handle the equal case? Maybe I do. And now I turn this into linear search for the smaller cases. Okay. And then now let me. The reason why I do this is that it allows me to kind of handle the boundary conditions with better. But whoops. But yeah, I think I just missed the -1 because I was rushing it a little bit. It was a long judge. Oh no. Another off by 1. Which one is that? Oh, I think it's just one of my randomness ones. Where there's certainly, oops. I don't even know how many other, things are there. I am just. I guess if this is equal, then I just return head. Is that true? That seems a little off. Oh my god. Maybe I need to start from 1. Or maybe this +2 is messing it up. Is that absolute max? I guess so. I don't know, friends. One of those problems where even that is frustrating that I'm having a weird off by 1, even though not that much code for it to be that wrong. Maybe you gotta fix that actually, because I think that I didn't fix it since it defaulted to head being it. But man, this submission was. Oh, I guess there's no way that's a few seconds ago, right? Okay. Maybe I'm just really off by 1 or something. Hey, what's up? Yeah, I'm getting an off by 1s. And this one is still off by 1, so I don't know. It's just that I all right. Oh, cool. Congrats. Is this right? Yeah, no, this should be right. I don't know. Well, now the same problem is giving me even more. Alright, let me think a little bit. All my usual thingies have been off. So I'm in Java. For a second, I was like, maybe I need this to be something else. But I have no idea. Am I at least no? Let's do 1, 2, 2, 3, 3. I feel like I'm just off by 1, but except for this case where it's off. I think the alternative thing I can do is count this as a double. Would that even be better? No, it's the same thing, really. Does this have an overflow? I thought, okay, let's take a look real quick, because I do worry about, I don't think so, though. We talked about the math, and yeah. No, so it doesn't overflow. Okay, that's good. Not the equal sign one, maybe? You gotta be kidding me. Alright, let's just YOLO this. Okay. I mean, it's definitely fast enough. I don't know. I tried like 10 things, so I can't even, to be honest, because I tried 10 things, I'm a little tired, and also like, yeah, I would have to kind of revisit this at some point. And I spent 25 minutes debugging this binary search. And it ended up taking me about 40 minutes. So I solved this in about 10 minutes, and then spent 25 minutes on like this equal sign, really. And I think that is something that I need to kind of practice on about. So it is a good, just try to figure out what it is. And kind of considering the lower bounds and upper bounds, yes, exactly what Brax kind of linked. Yeah, I'm trying to. Oh, there you go. I am trying to. I mean, I do have this template up mentally, right? It's just, I don't know. I think maybe my understanding of the edge cases is, or like, it's not even that my edge cases are 1%. I mean, well, they are in anyway, but I think for me, I just have to think about, like, I think for me, like, you're right in that, for certain problems, hey Sorex, for certain problems, you're right in that, in like what I need to do. But I think for me, I'm trying to figure out like how to learn about this in a meta kind of way, and what I mean is like trying to figure out learning itself and thinking about how is there like a mental model that I'm going through that's like a little off for some reason. I mean, like the code, like I can do it and you see it and all that stuff, but but yeah, but that's kind of the things that I'm thinking about in terms of how to kind of structure it in a consistent way, but also just making sure that I don't have off by once. That's a big one. But even just like understanding it and converting the edge cases and what do the edge cases mean, right? And I think, yeah, I would definitely have to kind of spend some time to kind of really dig into it fundamentally. And yeah, but I mean, I think like the general idea, like I obviously got pretty quickly, but I have to really think about the edge cases, which in this case is like, well, if you see three numbers before a number, what does that mean, right? And I think that's the part that like I have to consider the left bound and the right bound, which is kind of similar to what you're saying with upper bounds and lower bounds. And I need to kind of have like a plan attack that's consistent, so I don't do silly things like spend 25 minutes on a problem that I solved already, essentially. But yeah, cool. Again, for interviews, binary search problems are very almost said straightforward, but I meant like very fundamental and expected. This is probably a little bit on the harder side, especially when you deal with the off by ones. If you're on, I think if you're on an interview, you probably get away with the off by ones only in the sense that, like you got 90% of the problem right, but of course on the programming part, you don't get any credit for the last 10%. But yeah, now G-codes plus of course exists. You can do. You don't know what this means? Come on, that just that does stuff. It just means head is equal to 2, a positive 2, in case you're wondering. So don't be fooled. But anyway, but yeah, that's what I have about this problem. Definitely recommend binary search in general, though this is just trickier to get in general. I mean, I think the numbers and the analysis is straightforward, or like I got it. It's just that I have to get the boundaries right. But yeah,